glioblastoma, invasive breast cancer, melanoma.
Not many people have an opportunity to leave a footprint on this planet when they leave, and I see unique opportunity to do something that matters, to have a long-lasting effect on humanity. A number of years ago, we discovered that cancer cells have an enormous appetite for the vitamin folic acid. Cancer cells that must divide rapidly need a lot of this vitamin in order to continually proliferate. We use the vitamin as a Trojan horse and attached bright fluorescent light bulbs to them so that they would home in on the tumor and then light up the tumor so the surgeon could see it. That would enable the surgeon to remove more malignant tissue than he or she otherwise would be able to do. We envisioned this long ago and interestingly conducted studies in tumor-bearing animals and showed that we could very quickly and easily illuminate the tumors and allow them to glow and be easily distinguished from adjacent healthy tissue 15 years ago. And we couldn't get anyone interested in it until we established a relationship with a Dutch group headed by Dr. Go van Dam in Groningen, and he was very interested in this. He's a surgeon over there in their medical school, and he ran with it. He introduced it into humans and showed fantastic results. Shortly before surgery, usually an hour or so before the patient is wheeled into the operating room, he or she is injected with this tumor-targeted fluorescent dye. And it's allowed to distribute throughout the body, but it is only captured and retained in the tumor tissue, and the dye then clears completely from the healthy tissue. Then the surgeon proceeds to perform the surgery as he or she normally would do so. And as the clinical trials are designed right now, after completion of the surgery, using standard methods, they then turn on the fluorescent lamp to see what residual cancer they've left behind. If they just turn on the fluorescent lamp and they don't have any other room lights on, then the cancer glows like stars against a black sky. To date, all of the fluorescent tissue that has been resected by the surgeons has turned out to be malignant tissue. They've been finding roughly 5 times more malignant lesions that they missed than those that they were able to detect by standard methods. And so it's looking like it can turn into a very, very valuable tool for these surgeons. And ever since that initial publication, there's been tremendous interest. And the interest is increasing now. It's growing very rapidly. It's been tested at a number of hospitals around the country, including Mayo Clinic, University of Pennsylvania, Indiana University, in Europe at University of Groningen, University of Leiden, and so forth. The reason why I think this is so important is that we're still not curing many cancers, and the only sure treatment for cancer is to cut it all out. And if the surgeon can see it all, he or she can easily remove it. But if you can't see it and you can't feel it and you can't detect it, it's going to stay there, and the patient's going to be sewn back up with the disease inside, and the cancer will recur, and the prognosis then is very poor. My lab started like every other lab at Purdue with just myself and nobody else, and gradually over time it's enlarged and grown into a fairly good-sized research group. Now there are well over 20 full-time researchers in the lab. We've been very blessed by the generosity of Purdue University in building this drug discovery building, which, as you can see around you, is a fantastic new facility. The research proceeds much more smoothly here. The equipment, the facilities are all state-of-the-art, and it really is accelerating the pace of our work. My hope is to develop tumor-targeted fluorescent dyes for every cancer known to man. I think that objective is achievable. I think we can at least cover most cancers and enable surgeons to be able to see the disease very easily and quickly.